in the morning, guys.
Yeah, I don't know. Okay, so we are going to do graphing linear inequalities, and we are going to do graphing linear systems of linear inequalities. Okay, we've done inequalities before, but we've only done inequalities where there was one variable. Now we're going to do inequalities where there's two variables. Okay, it's essentially the same exact as graphing your lines. The main difference is that you're going to have two different types of lines. You are going to have solid lines, and you are going to have dashed lines. So I'm getting my colors out. Okay, so we have this little chart here to help us. If you see the equal to line under it, we are going to graph a solid line. Again, if you see the equal to line under it, we are going to graph a solid line. We will go over what a solid line looks like, okay? So again, if you see the solid line under the inequality, you graph a solid line. Now these bottom two, see how you don't see the solid line? That means they're not going to be solid lines when you graph. They're going to be dashed lines. And we will go over what a dashed line looks like, okay? So that's the first thing that's going to be different from just graphing our linear functions. Sometimes you're going to have a solid line, sometimes you're going to have a dashed line. Then we are going to shade half of our graph. We're either going to shade above the line or below the line, okay? So this is what kind of symbol? There's the equal to under it, but what's the inequality sign? Less than. So this is a less than or equal to. Another way to help you know which way to shade, see how that helps you make a D for down? Do you see how the less than sign can be turned into a D for down? So if you have a less than sign, you are shading down or below the line. If you have that symbol, that is what sign? What inequality sign? Greater than. That can help you make a P for up. I know, guys, I'm sorry. I'm going to email somebody to see if we can get something for the smell. Do y'all want? Okay, we'll make it more important, I guess. Okay. So again, this one can help me make a what? A D or a P? A D. So this one means I shade down. This one helped me make a D or a P. P, so this one I shade up. Guys, this is the trickiest part. Knowing when to use a solid line, when to use a dashed line, when to shade up, when to shade down. Okay? I just sprayed a ton of... Okay, so this is just like graphing our linear functions. We need our M and our B. So looking at this equation, looking at this inequality, y is less than or equal to 2x minus 3. What's my M? 2, and for graphing purposes, I always write it as a fraction, 2 over 1. So I visually see my rise and my run. What's my B? Negative 3. So guys, so far, nothing different, okay? Where am I going to begin when I graph? Negative 3 on the y-axis. How do you move from that point? I always go up, so up 2, and since it's positive, right 1. So from this point up to right 1. Put all your points on there. Do not automatically draw your line though, okay? Just put the points. What's the opposite of up to the right? Bless you. Again, do not automatically draw the line. Okay, looking at this inequality sign. Do you see the solid line under it? Yes. so this means it's going to be solid. And does that help me make a P for up or D for down? D for down. So this is going to be a solid. And what a solid line looks like is all of our lines that we've been drawing. All of our lines for our linear functions have been solid lines. What goes at the end of my lines? Arrows. So a solid line. And I am shading down. Do we see how the line has separated my graph into two regions? This left part, this right part. Which one's going to be the down? The left or the right? So kind of the way I look at it is look at your y-axis. Am I going to shade the part that has the arrow going up or the part that has the arrow going down? The part that has the arrow going down because we're shading down. So I am shading this region. Does it have to be perfectly shaded? No. Please know that your x and y axes don't affect where you're shading at all. Okay? The only thing is that line we just graphed on our coordinate plane. Okay, so what makes this different than linear equations? What do you think that shaded region represents? There you go, all possible solutions. So let's write that up here. Shaded region represents all possible solutions. So no longer are just points on your line solutions. Any point that is on your solid line is a solution, and any point in the shaded region is a solution. Okay? We good with that? So again, main difference is solid line if you see the equal to line under the inequality sign, dash line if you do not. Shade above if it's a greater than, or shade up if it's a greater than, shade down if it's a less than. Good? Okay, next one. Wah, wah. Sometimes they're not going to be in y equals mx plus b form. So what do we need to do first? Solve for, we want to have y equals, so we're going to solve for y. Draw your line through the inequality, circle your y. I want y by itself, not 3y, I want y completely by itself. So remember, you always move what's not glued to it first. So how are you going to get rid of a minus 2x? So then I get 3y is greater than, are these like terms? No, so I can't combine them. Which one should go first? The 2x's go first. Very good. So 2x plus 6. Are we good with that? Okay, keep your y circled because we still don't have y by itself. So what do I do to get y by itself? Divide everything by 3. So the 3 over 3 cancels, and I get y is greater than. Does 2 over 3 simplify? What's 6 divided by 3? 2. So is this now in y equals mx plus b form? Yes, what's my m? And what's my b? So where do I begin when I graph? 2 on the y-axis. How do I move from that point? Up to right 3. What's the opposite of up to the right? So down to left 3. Again, do not automatically draw your line because we don't know what kind of line it is. Okay? Do you see the equal to line under it? No. So this inequality sign lets me know that I'm going to have a dashed line. What does a dashed line look like? It's still going to be straight, but you're just picking up your pen. See how this is not solid? There's breaks in it. Again, it still makes a straight line because lines are straight, but you just pick up your pencil. You don't continually draw it. Okay? We good with that? Okay, now we're missing the shading part. Are we going to shade up or down? Look at your inequality sign. Does this help me make a P for up or a D for down? A P for up. So I'm going to shade up. So what part is that going to be? Region 1 or region 2? 1. Remember, up, I'm going to shade the part that has the y-axis with the arrow up. So I'm shading this whole top part of the graph. Another thing you can do, because really guys, the trickiest part is knowing which way to shade. You can choose a test point. What does that mean? Do we see that the ordered pair 0, 0, or the origin is clearly below the line? Okay, so let's use 0, 0. What's 3 times 0? What's 2 times 0? So this left side would become 0. Is 0 greater than 6? No. So 0, 0 is not a solution, so I should not shade the side that has 0, 0 on it. Okay, I should shade the opposite side. What if I got a true statement? Then you would do what? You would shade the side that has the origin. Okay, I would always use the origin as our test point. Okay, unless it's on the line. That's the only time you can't do it. Okay, now we've done one solid line and one dashed line. What do you think the difference is between having a solid line or a dashed line? How does it affect our solutions? Yes, Dylan?
The solutions on the line aren't possible solutions.
If it's what? You're correct, but if it's what kind of line are they not solutions?
Yeah.
If it's a dashed line, very good. So we are going to write points on a dashed line are not solutions. That's why it's dashed. You don't have that equal to, so points on the line aren't solutions because it can't equal the line. You don't have the equal to, okay? Do y'all remember that that's the difference of whenever you have an open or a closed dot when you do your inequalities on a number line? The open dot means we don't include it. That's not a solution. The closed filled in dot means we do include it. Okay? Next one. Oh no. Again, it's not solved for y, so we need to solve it for y. Draw your line through the equality. Circle y. What am I going to do to get y by itself? Subtract x. Great job. When I drop down my 3y, what's in front of the 3y? Negative 3y. Very good. Are these like terms? What should I write on the right-hand side? Negative x minus 6, because the 6 is negative. We good with that? Circle your y. What do I need to do to get y by itself? And do we remember what happens when you divide by negatives, guys, when we're doing inequalities? Flip. Because you divided by a negative. So instead of a greater than, it's now going to flip to a less than sign. The negative 3 over negative 3 is going to cancel, and I get y is less than. What's negative x over negative 3 become? A negative over a negative is positive. X doesn't have a coefficient, so it's an understood 1. So what's that? Positive 1/3 x. And what's negative 6 over negative 3? Plus 2. So now, are we in y equals mx plus b? What's my m? 1/3. What's my b? So where do I begin? And how am I going to move? Up 1, right 3. What's opposite of up to the right? Okay, do not draw your line. Looking at this. Oh no, I made a mistake. Do y'all see my mistake that I made? Anyone? You shook your head yes, Renee? What did I do wrong? See how this was a greater than or equal to and I left off the equal to? Sorry. Okay, so now looking at this inequality sign, is that going to be solid or dashed? Solid. I see the solid line under the inequality, so it makes a solid line. Okay. Does that help me make a P for up or D for down? Helps me make a D, so I'm going to shade down. So is that region 1 or region 2? 2, because the bottom part of the y-axis, the part that's going down, is where I'm wanting to shade. Do not change your page yet. We're going to write a little note below this as well. Okay, what is true about points on a solid line? They what? They are solutions. Very good. Points on a solid line are solutions. Y'all can't see that. Points on a solid line are solutions. Good? Questions? Okay. Now we're going to go on to our special cases. How do you know you have a special case when you're graphing? There's only one variable. Here, I only have a y. So what's my acronym if I only have a y? HOI. What's the H stand for in HOI? Horizontal line. So this is a horizontal line. Horizontal line. So I'm going to go on the y-axis and put a dot at 3. Okay, we still need to know if it's solid or dashed. Looking at your inequality, do you see the solid line under it? No, so this is dashed. So a horizontal dashed line where y is 3. Again, a dashed line just means it's not connected. You have to pick up your pen, pick up your pencil. There are breaks in the line. Okay, does this help me make a P for up, D for down? P for up. So I'm going to shade above the line. Done. We good with that? We like the special cases. If you remember them, they're like the easiest ones to do, right? Good? Okay, next one. How do I know this is a special case? You only have an X. There's no Y. You only have an X, so what's my acronym? Bucks. So what's the B stand for in bucks? It's a vertical line. So I'm going to go on the x-axis and put a dot at -4. Before I draw my line, I need to know, is this solid or dashed? You see the line under it, so it is a solid line. And it's a vertical line going up and down. Now, does this help me make a P for up or a D for down? D for down. However, if you have a vertical line, is there a top and bottom? No, there's a left and right. Okay? So if it says X is less, where's the less side on your x-axis? To the left or to the right? To the left. So I am shading to the left. That's really the tricky part. And again, you could use a test point. Use the origin, 0, 0. Is 0 less than -4? No. So I shouldn't include the origin. Do not include 0, 0. Good? How do we feel about graphing our linear inequalities? It's a good review of graphing linear equations, right? Make sure it's in y equals mx plus b. Begin with b, move with m. Good? Okay, now we are going to look at how to determine if something is a solution without graphing it. Okay? You have your inequality and you have an ordered pair. How can I determine if this ordered pair satisfies that inequality? If it's a solution to the inequality? Plug it in. I have an x value and I have a y value. So I can rewrite my inequality, and what am I going to replace y with? 0. So 0 is greater than 2/3 times x. What's x? 1, bless you, plus 2. So guys, what I would is drop down my 0 is greater than, I would put this whole right side in the calculator. So I would do alpha x, to put my fraction in, 2/3 parentheses 1 plus 2. Okay, 2/3 times 1 plus 2. And I get 8/3. Is 0 greater than 8/3? No. So this does not work. So is it a solution? So I would say not a solution. Because you do not get a true inequality. Good? Next one. Again, you have your ordered pair. Label it x, y. Rewrite your inequality. Instead of y, what am I going to put? 8 is greater than 2/3 times x, which we just labeled 4, plus 2. Drop down your 8 is greater than, and I'm going to plug the whole right side in the calculator. Remember, I showed y'all kind of the quick way to do this. Since I'm retyping the same thing in every single time, I'm just changing what the x is. If you arrow up and highlight what you're wanting to retype in the calculator, hit enter. Change that 2 to now what? 4. Sorry, change the 1 to now 4. And I get 14/3. you don't know what 14 over 3 is, how can you change that to a decimal? Math, go down to decimal, enter, enter. So it's 4.6 repeating. So is 8 greater than 4.6 repeating? Yes. So is this one a solution? Yes. It is a solution. Again, guys, we have 5 class periods until start. We want as much of this to soak in. I'm going to help you as much as possible with the calculators and how to do things well on the calculator. Let's make sure we are all paying attention. Okay? Remember, if we pass our STAR test this year, you never have to take another math STAR test again, ever, which would be awesome. Okay? Next one, label your ordered pair. X, Y. I'm going to write my inequality, but instead of Y, what am I going to put? Is greater than 2/3 times, not X, what's X? -6 plus 2. Drop down your -2 is greater than, and again, I'm going to arrow up until I get to what I'm wanting to re-put in the calculator. And I'm just going to change this to a -6. And I get -2. This one's tricky. -2 is equal to -2. But is that what that inequality sign says? No, it says -2 is greater than -2. Bless you. Is -2 greater than -2? No. So this one is no, not a solution. Are we okay with this, guys? Can we skip the last two? Okay. Now we're going to go on to systems. Okay? Systems just mean we are going to graph how many inequalities on our graph? More than one. And in our case, we're only ever going to do 2. Okay? So, the only way to solve a system of inequalities is by graphing. Y'all just took your test over solving systems of equations, and we taught you substitution, elimination, and graphing. You cannot substitute or eliminate if we have inequalities. You must graph. Okay? So the only way to solve our system of inequalities is to graph. In order to solve these systems by graphing, you must graph both of them and find the region that satisfies both inequalities. So what that means is you're looking for the double shaded region. Okay, you're looking for the overlap. Okay? We good? Okay, number 1. How am I going to graph x is greater than 5? It's a box. So I'm going to put a dot on the x-axis. 1, 2, 3, 4, 5. Put a dot at 5 on the x-axis. The V stands for vertical. Okay. What kind of line do I have? Solid or dashed? It's going to be dashed. So I'm doing a dashed vertical line. Dashed vertical line. Okay, which way am I going to shade? But again, there's not really an up and down. So which way am I going to shade if it says x is greater? Where are greater x values? To the right. Your vertical ones are the hardest ones, guys. So I'm going to shade to the right. Okay, now we're going to graph y is less than or equal to 4. That's also a special case because you only have a y. What's my special case acronym for this? Hoy. It's a hoy. So I'm going to go on the y-axis and put a dot at 4. Is this one solid or dashed? Solid. And what's the H stand for in hoy? Horizontal. So it's a solid horizontal line. Does that help me make a D for down or a P for up? D for down. So I'm going to shade down. Do we see our double shaded region? Do we see the overlap that is shaded both blue and pink? Hello? Yes? No? Yes. So this area right here, that is the double shaded region. Where the solutions are. So if I have a point that's just in the pink shaded region, would that be a solution to the system? No, it would only satisfy the pink inequality. What if it was in the blue shaded region? No, because that would only satisfy the blue inequality. For it to be a solution to the system, remember it must satisfy both inequalities. Okay, so we are going to plot some points and say yes or no. Are these solutions? So looking at point 8, -4. Where is 8, -4 on my graph? Tell me how to plot 8, -4. 8, -4, Marissa.
You would go 8 to the right and then down 4.
Very good. That is 8, -4. Is that in the double shaded region? Yes, so is that a solution to the system? Yes. Okay, how would I plot 5, 0, Yusra? How am I plotting 5, 0? 5 on X. Do I go up or down at all?
No.
Okay, so there's 5, 0. So that's bordering the double shaded region, so it might be a solution. But what kind of line is it on? Dashed line. When we did our linear inequalities, what did we say about points on a dashed line? They're not solutions. So would this be a solution to the system? No. On a dashed line. How am I going to plot the point 10, 4, Lexi? Remember, ordered pairs are x, y. X is your...
To the right 10 and then up 4.
Very good. Right 10, up 4. So that's also on a line that is bordering the double shaded region. What kind of line is that one on? Solid line. If it's on a solid line that is bordering the double shaded region, do you think it's a solution? Yes. On a solid line that borders the double, I can't spell double, shaded region. The explanation, guys, that's really just for us, okay? A simple yes or no would work, okay? Good? How are we feeling about these? Not too bad? Good. Next one, y equals mx plus b. Are we already in slope-intercept form? What's my m? Do we include the x though? It's x's coefficient, but we don't include the x when we say our slope. Again, for graphing purposes, I'm going to make it a fraction, 2 over 1. What's my b? 3. So where do I begin? On the 3 on the y-axis. How do I move? Up to right 1. What's the opposite of up to right 1? Remember, biggest thing, do not automatically draw your line when we're doing our inequalities. We need to know if it's solid or dashed. So, looking at the inequality sign, do you see the solid line under it? Yes, so it's going to be solid. Draw your solid line. Does this inequality sign help me make a D for down or a P for up? D for down. So I'm going to shade down. Is that region 1 or 2? 2, because I want the bottom part of the y-axis. That's my down region. Peyton, what's my slope of my second line?
Go ahead, negative x.
Put the two answers together.
1.
You had a negative first.
Negative 1.
And do we include the x though?
No.
So my slope is just,
Negative 1.
and again for graphing purposes, I make it a fraction. So I visually see my rise value and my run value. Very good. What is my b or my y-intercept, Syra?
3.
For this one?
1.
1. So where do I begin when I am graphing, Leo?
On B or 1 or A?
Where do we begin? What does begin with? What letter?
Oh, negative 2 and negative.
We're right here, sweetie.
Oh, 0.
What's my b value?
Oh, 1.
So where do I begin?
No.
On which axis?
On the x-axis. Y-axis.
Oh, y-axis. There we go. How am I going to move from that point, Heather?
Down 1, right 1.
Down 1, right 1 again. I always like to go up, so I'm going to go up to the left. Is up to the left the same as down to the right? Yes. Personal preference, I always go up first. But your answer was correct, Heather, because the opposite of up to the left is down to the right. Remember, we read our graphs left to right. Since it has a negative slope, as I read my graph left to right, it should be going downhill. Again, do not draw your line. Alex, should this be dashed or solid?
Oh, it should be dashed.
Dashed, because you don't see the solid line under it. So this is a dashed line. Are points on a dashed line solutions, guys? Never, whether we're doing systems or just linear inequalities, not systems. Points on a dashed line are equivalent to an open circle. They are not solutions. Okay? Does this help me make a P or D, guys? P or D? D for down. Hello. Alex, go to grade level. So we said, what'd we say? D for down. So I'm going to shade region 1 or region 2? 2. Do we now see our double shaded region, our overlap? Yep, it's right here. Okay, so the point 0, 0. Heidi, is the origin a solution to the system? Yes, 0, 0 is right here. Is that point in the double shaded region? Yep. Okay, what about negative 2, negative 1? Monet? First of all, tell me how to plot it. Left 2, down 1. Okay. Is it bordering the double shaded region? Yes. And it's on a line, right? What kind of line is it on, Monet? Are points on a solid line solutions? If it's bordering the double shaded region. So this is a yes. Guys, the points on the lines are the tricky ones. Okay, you need to know if it's on a solid line or a dash. If it's a dash line, the answer is always no. The solid line sometimes could be yes, sometimes could be no. It's a yes if it's bordering the double shaded region, and it is a no if it is not. Okay? How am I going to plot the point 2, 7, Thomas?
Right 2, down 7.
Positive 7.
Up 7.
There you go. Right 2, up 7. So it's on a solid line. So points on a solid line are solutions. Is this going to be a solution though, Thomas?
Yes.
Is it bordering the double shaded region?
No.
No. So is it going to be a solution?
No.
It is a solution to the pink inequality, but it is not a solution to the system because it is not bordering the double shaded region. That's what I was saying. The points on a solid line are tricky. Okay? Sometimes points on a solid line are solutions and sometimes they aren't. It depends on if it is bordering the double shaded region. We good? Guys, are we good doing one more? We feel like we've graphed a lot of inequalities today. Yes? Okay. Wah wah. This one is not solved for y.
Wah, wah. No good.
Don't make fun of me.
All right, quick question. Y'all don't make fun of me.
Y'all should.
All right, so I was trying to do this one kid that's not here just to,
Uh-huh.
and it says the end of the test when 122.
It doesn't say end of test. It says
What?
end test.
Oh, end test, but that doesn't go past 22. I can't.
You can't do next?
No, it's the last one.
See how it says next?
One.
I'm gonna try that.
Come on.
I'm just listening to my students.
Come on.
I shouldn't listen to my students, should I?
No.
All right.
No.
We'll see what happens.
Yeah, you should be able to keep going.
Okay.
Welcome, welcome. Okay, we need to solve for y. Draw my line through the inequality, circle y. What's going to be my first step, Ben?
To subtract x.
Subtract x. Great job. Move over what is not glued to the variable we're solving for first. Put your x term before your constant. Morgan, you awake with me? What do I do next to get y by itself?
And you're going to divide by 6.
There we go. Stay awake, okay? Again, we have 5 class periods until STAR, guys. Have as much algebra soak into our brains as possible. You need to be awake for that to happen.
Soak it in, just like a sponge.
Right, when I click next question, it shows that. When I click the arrow.
Huh. That's a good question then. So are the kids, have any of the kids been able to go past 22?
No, they said that was the last one they could do.
Huh.
And so I'm doing this on the one that's absent. And
Huh. I will look at it
So
and
we'll
see
stop
if
on-
my kid, yeah, we might be stopping on 22.
All right.
That's gonna put did they do it from the secure test browser?
Well, which I didn't, but theirs,
They did?
yeah, they were logged in.
And then they
not
did the
logged in on computer,
practice
but
test.
Practice test, yeah.
And they did the 2021
Algebra.
algebra?
The others are biology, English. That's the only one that showed for algebra.
Huh. I'm doing one more problem with them and then I'll get on and look.
I may check at the end of the period. At least we're up to 22.
Okay, so my 2's cancel and I get y is less than, what's negative x over 2 become? Negative 1/2 x, very good. And then 6 over 2 plus 3. Are we now in y equals mx plus b, slope-intercept form? What's my m? And what's my b? Where do I then begin, Dominic?
3 up in the y-axis.
Great job. How do I move from that point, Dylan Halverson?
Oh, where are we at?
I plotted my beam of being 3. Now we're going to move. I'm on this one.
Up 1, left 2.
Great job. Up 1, left 2, since it's a negative. Or down 1, right 2. Okay, is this a solid or dashed line, Michaela? It's going to be dashed, because you do not see the solid line under the inequality. Again, if you do not see the solid line, it does not make a solid line. If you do not see that equal to line, it does not make a solid line. Does this help me make a D or a P, Dylan Day? D for what?
Down.
D for down. So I am going to shade down. Is that region 1, 1 or 2, Nicole? 2. Oh no, my highlighter's running out. Guys, your highlighting doesn't have to be perfect, okay? Just clearly needs to be able to see where you are shading. Okay, we good with that one? Miles. Miles, what are we going to do for this next one to solve for y?
3x.
Subtract 3x. Great job. So be careful. I have a negative in front of my y, so drop down the negative with the y. What am I going to do next, Lexi, to get rid of the negative with the y?
Divide.
By? Negative what?
3.
What's with the y?
Oh, 1.
Divide by negative 1. Very good. If there's no coefficient, you have an understood coefficient of 1. Divide everything by negative 1. What happens when you divide inequalities by negatives, guys? Flip the inequality sign. That is the biggest mistake when we're doing our inequality. So now instead of being a less than, we're going to be a greater than. Y equals mx plus b. What is my m, Leo? Y equals mx plus b. What's my m?
3.
And I'm going to write it as 3 over 1. What's my b, Heather? Y equals mx plus b. Negative 4. Very good. So where am I going to begin, Marissa?
You're gonna the y-axis at -4.
Great job. How am I going to move, Peyton?
Up 1, up 3, right 1.
Very good. Up 3, right 1. Opposite of up to the right, down to the left.